Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So in this video, we are going to learn about one of the discrete probability distribution, which is negative binomial distribution. A negative binomial has the same properties with binomial distribution, where each trial has two possible outcomes, where we define it as success or failure. Okay, so the probability of getting success will be P and probability of failure will be 1 minus P. And the second properties is each trial is independent on each other. That is, the outcome on one trial does not affect the outcomes on the other trials. Okay, so you can see that the negative binomial has the same properties like the binomial. So what's the difference between negative binomial and binomial? So the obvious difference between binomial distribution and negative distribution are as following. As I mentioned before this, for binomial, the number of trials n is fixed. Okay, so the discrete random variable x, okay, this x represent the number of success in n trials, given the formula would be this one. However, for negative binomial distribution, the number of trials is not fixed. So this x, discrete random variable, represents the number of trials until r success occurs. So meaning this x is number of trials, r is given as number of success, p is probability of success, 1 minus p is the probability of failure. Okay, given x is equals to r plus 1, r plus 2, and r is given as 1, 2, 3. If the probability of success on individual try is p, then the negative binomial random variable can be represented as this discrete random variable x follows negative binomial. R is number of success and P is the probability of success. So the definition of X, given that the number of try it takes to get the R success, where the number of trials defined as our X, this small x. Okay, so the probability distribution of X is given by this formula. Probability of X equals to the number of trials would be equals to X minus 1 combination of R minus 1 P to the power of R 1 minus P to the power of X minus R. And this is the value for X starting from R plus 1 and so on, and R starting from 1 to 3. So note that X minus 1, R minus 1 is given as this. X minus 1 combination of R minus 1. Okay, so for the negative binomial, the expected value for mean would be, or mean of X is given as R over P. And then for the variables of X would be R times with 1 minus P divided by P squared. So these are the formula that you need to know. Okay, so let's try this example. A fair die is toast. What is the probability number 6 appears for the third time in the fifth toast? So this question is a bit different from the binomial distribution. Okay, so you can see here we have to find the probability of number 6 appears, meaning that for this experiment there are two outcomes. Okay, it's either you get 6 or not 6. Okay, so we want to find probability of getting 6 for the third time. Okay, so this would be our success, number of success. So how many trials? The trials would be in the fifth toast. Okay, so a bit explanation on this example. So we say that this is negative binomial because the first one, it consists of repeated trials, okay, where the number of trials are not fixed. like binomial. Okay, so for this experiment, we toss a die repeatedly until the 5th toss. And then the second one, it is negative binomial because each trial can result in just 2 possible outcomes, either 6 or not. And the third one, the probability of success, given success is getting 6. Okay, get 6 is constant. Okay, so it will be 1/6 on every trial. Okay, and then the fourth one, the trials are independent. That is, getting number 6 on one trial does not affect whether we get number 6 on the other trials. Okay, so in summary, okay, the experiment continues until a fixed number of success have occurred. So in this case, 3 times number 6 appears. Okay, so this would be our number of success and this would be our number of trial. Okay, so how can we write this in the mathematical way? So, okay, so this is our success where this is our trials. Okay, so remember for the negative binomial, the discrete random variable, okay, considers that we want to find the number of trial in R success. Okay, so this will be defined as R and number of trials will be our X. Okay, so for this case, X followed by binomial, R is given 3 and P will be 1/6. Okay, so which is this one. Okay, now we know X is our equals to 5 and R is equals to 3 and we know our P of getting 6 is 1/6. So we know all of this value, so we can substitute into the formula. Okay, so we have 5 minus 1, C, 3 minus 1. Given this 5 is our X, this is our R. Okay, so P to the power of X, P to the power of R, and then 1 minus P to the power of X minus R. And you will get the answer, which is this. Okay, so the probability of getting 6 for the third time in the 5th dose would be equals to 0.019. Now let's try another example. A door-to-door salesperson is required to document 4 in-home visits each day. Suppose that she has a 25% chance of being invited into any given home. Okay, so what is the probability that the 4th invitation is obtained from the 9th house visited? Okay, so our aim is that we want to know the probability of the invitation is obtained from the 9th house visited. Okay, so we need to identify what is our P, what is our number of trials, and then number of success, which is given as R. Okay, so this 25% chance would be the probability. Okay, given probability 0.25 is the probability of being invited. Okay, so this answered our question. What is the probability that the 4th invitation is obtained from the 9th house visited? Meaning that the probability of them getting invited. Okay, and given that this 4th invitation is the number of success. Okay, so this will be your success of getting invited. So number of success is given as R. Okay, this will be your 4. And the 9th house is your trial, meaning that you have gone to 9 house and that 9th house is your 4th invitation. Okay, so this will be your 9. Okay, so remember for the negative binomial, we take consideration on the number of trials, okay, not number of success. So X will be equals to number of trials, which is 9, x is equals to 9. So the formula would be x minus 1 CR minus 1 and then 0.25 to the power of R, 0.75 to the power of 9 minus 4. So the answer would be 0.0519. Okay, so another clue is that the number of tries always should be greater than or equals to R. Okay, so it is always must greater than or equals to R. So now please do this exercise. Please pause this video. Once you're done, please comment in the comment box and write your answer for exercise 3.4.1. And write down your name and also section. Now let's try the last exercise. Please pause this video and please comment your answer, your name and also your section in the comment box. Thank you.